Let's discuss question number 30 from test 4. This is from machine design, or probably basic strength of materials, because thin cylindrical shell. So thin cylindrical shell of length 3 meters has an internal dia 1 meter and the thickness is 15 mm. So it's really thick. Okay. Find out the change in the diameter of the shell if it is subjected to internal fluid pressure of 1.5 Newton per mm squared, so that is MPa, and Young's modulus is given as 2 into 10 power 5 MPa, and Poisson ratio is given as 0.3. Okay, so first, in order to find out the change in diameter which comes from strain and strain comes from stresses, if you take any element on the circumference of the thin cylindrical vessel, you have two types of stress. One is the axial stress or the longitudinal stress. The other is the hoop stress or the circumferential stress because of the internal pressure. So now we know that this is your sigma c circumferential direction and this is your axial direction. Okay, and I need to find out the change in the diameter in this diameter, because diameter will be in the circumference. So the change in the diameter or circumferential strain. So first let's find out the strain in this direction. The strain in the circumferential direction is basically sigma in that direction by E, but then you have two-dimensional stresses, so the Poisson effect has to bring in. So because of the stretching in axial direction, there will be a decrease in the strain in the circumferential direction. That is this term. Okay, so I need to find out sigma c now. So 1 by E sigma c, I know the circumferential stress for a thin pressure vessel. Circumferential stress is PD by 2T and the axial stress is PD by 4T. So if I substitute that, I get PD by 2T minus nu PD by 4T. So if I just take out calm on PD by 2T E, it will be 1 minus nu by 2. So this is my circumferential strain. Now circumferential strain is nothing but change in the length. Now strain the length, change in the length in the circumferential direction. This length is basically pi d, and the new length will be, say, pi, the new diameter. Okay, so change in the length will be pi d nu minus initial length pi d by pi d. So this is your circumferential strain, and this is your pi d by 2t epsilon 1 minus nu by 2. So what we need to find is the change in the diameter. So the numerator pi gets cancelled, the numerator gives the change in the diameter by the diameter. So this is PD by 2t epsilon 1 minus nu by 2. So the delta d, the diameter would be P d by 2te, so d square 1 minus nu by 2. Now it's all a matter of substituting the values. So let's substitute the values. So pressure is given as 1.5 MPa. The diameter is 1 meter, so we need to write in mm, so 1000 mm square, but thickness is 15 mm. So E is 2 into 10 power 5 and Poisson ratio is 1.1 minus 0.3 by 2. So this, when you calculate, it comes out to be 0.2125 mm, and it nicely comes out to be 0.2 mm. There is no fraction thing. So the change in the diameter can be found out. So if you go back, what we have done is first list out what are the stress states, and now the change in length, if they would have asked, then you would have taken the axial direction. They have asked the change in the diameter, so you have to take the circumferential direction, and this is your circumferential strain. So first find out the circumferential strain in terms of both as it will be related because it's a 2D kind of stress, 2D state of stress. So this is how it turns out. So the answer is B. Option is D. Thank you.